the idea of slow light really came from first an experiment that was performed a decade ago with a group from Harvard who actually managed to slow the light down. And really, I mean, if you take light, it travels very fast in the vacuum at 300 kilometers per second. And what they managed to do actually, in an ultra-cold atomic cloud, they managed to bring the speed of light at the human scale. And that was really an unprecedented experiment that captured lots of imagination. So you can imagine light traveling at the speed of a moving bicycle, and that was really, it was a breakthrough at that time. So since then, there have been, of course, different methods to slow the light down other than this ultra-cold atomic cloud. And for instance, there is something that's called photonic crystals, and you take a medium and you perturb it in a periodic way, in a periodic fashion, and by doing so, you can force the light to be reflected back along the path, and that's overall the light is slowed down. And that's one other way to slow light down, and that's what we are exploring at IPOS. In the network, for instance, you know that the optical data are flowing, and you need to synchronize them and to optimize the flow of the data network, of the data through the network. Well, what you do is you need some buffers, for instance, optical buffers, that would temporarily store the data. And because it's very hard to stop the light, what we do instead, or what we think of doing instead, is to slow the light down, to store it temporarily in some medium. So that's one big application that has driven the interest in slow light, these optical buffers and optical delay lines. But we are still far from seeing it in a practical application, and they are still far from outperforming, for instance, electronic buffers.
Australian researchers, including myself, are really doing some pioneering work in diamond photonic crystal, and that's been recognized worldwide. We've been highlighted in research highlights in Nature Physics. We've been recognized by the world, recognized researchers who are doing, putting the same effort as we were doing. That means this is the recognition that you get from your colleagues. If they are starting to do the similar things and trying to achieve more in this field, it's the best possible recognition from the worldwide. However, there are many challenges. We are so far away from the quantum device. That means it's a long time to go, but it's really good. We started this research 3 years ago, and we were not very optimistic about the role of diamond in photonic crystal, and not even role in quantum computing. But now we have achieved so much in these 3 years' time that we are very hopeful, and the diamond photonic crystals are certainly the best room operating temperature quantum device possible. As far as diamond photonic crystal or diamond photonics is concerned, we just started. That means it will be developing, hopefully, and it will merge with industry at the end. And I hope to see the quantum device on the market. That's the final goal. But it is still really very challenging area, and that's really fundamental science at the beginning. But we hope to move towards the market and to obtain devices which are operational at room temperature.